topic for Lesson 1-1 is expressions and formulas. You'll learn to use the order of operations to evaluate expressions and use formulas. How are formulas used by nurses? Nurses setting up intravenous or IV fluids must control the flow rate F in drops per minute. They use the formula F equals V times D divided by T, where V is the volume of the solution in milliliters. D is the drop factor in drops per milliliter, and T is the time in minutes. Suppose a doctor orders 1,500 milliliters of IV saline to be given over 12 hours. Using a drop factor of 15 drops per milliliter, the expression 1,500 times 15 divided by 12 times 60 gives the correct flow rate for this patient's IV. A numerical expression such as 1,500 times 15 divided by the quantity 12 times 60 must have exactly one value. In order to find that value, you must follow the order of operations. First step, evaluate expressions inside grouping symbols such as parentheses, brackets, braces, and fraction bars. Use P to stand for parentheses and all of those other things. Evaluate all powers or exponents. Do all multiplication and or division in order from left to right, and do all addition subtractions in order from left to right. So there's the acronym that we've used in the past, PEMDAS. Find the value of the expression. So we need to start first with P, so working inside our grouping symbol. So I'm going to copy down the 384 minus 3 times 7 minus 2 is 5. And just copy everything else down. And then before I can get rid of those brackets, I need to simplify inside there. So I need to do the 5 cubed. So 384 minus 3 times 125, and divided by 3. 3 times 125 is 375. And the difference there inside the bracket still is just going to be 9. And finally 9 divided by 3 is 3. We'll use order of operations to simplify expressions after we've substituted in algebraic expressions as well. Variables are symbols, usually letters, used to represent unknown quantities. Expressions that contain at least one variable are called algebraic expressions. You can evaluate an algebraic expression by replacing each variable with a number and then applying the order of operations. So to evaluate, we're going to substitute 2 in for S, and 3.4 in for T. So every place there's an S, I need to substitute in a 2. And every place there's a T, I need to substitute in a 3.4. And so using our order of operations again, I want to look at getting rid of the parenthesis first, but before I can do that, I need to simplify the expression inside the parenthesis, which is going to lead me to the exponent. So I'm going to have, just copying down, 2 minus 3.4 times 2 squared is 4, minus 3.4, just copying it down again. 2 minus 3.4 times 0.6. Using a calculator, 3.4 times 0.6 is 2.04, or 2 400ths. And the last thing I have to do is subtract, so 2 minus 2.04 is going to be negative 0.04, or negative 400ths. Now you can see kind of the purpose in the book. They're going to write negative 0.04. So that 0 serves no purpose mathematically, but it helps the decimal show up better. Now, generally I think as we go to further examples it gets more difficult, but I think adding the fraction bar actually makes it easier. Evaluate, and we're just going to substitute in and do the stuff. So where there was an x, we're going to replace x with 5. Y is negative 2. and z is negative 1. And again, y is negative 2. Okay, now some people don't like to use the parentheses. It's not out of the way essential for the negative 1 to the third, because either negative 1 cubed without a parenthesis or with a parenthesis, either way it's going to equal negative 1. But in the denominator, without a parenthesis, we'd have negative 4, and with, we'd have negative times negative is a positive 4. So the parentheses do matter. Okay, a little bunny trail, but not too bad. 8 times negative 10 be negative 80, using our PEMDAS, doing all our multiplications. And that was plus negative 1, which I guess we could have just written minus 1. Negative 2 times negative 2 is 4, plus 5. So then we have negative 81 divided by 9. Negative divided by positive is a negative, and 9. Special case of using an evaluate is using a formula. A formula is a mathematical sentence that expresses the relationship between certain quantities. If you know the value of every variable in the formula except one, you can find the value of the remaining variable. Find the area of the trapezoid with base lengths of 13 meters and 25 meters and a height of 8 meters. When we did the area of a trapezoid verbally in geometry, I would read this as 1/2 the height times the sum of the bases. It doesn't matter which base is which. And they gave it to us all in the same units, so we don't have to worry about that. In this problem, they said the height was 8, and the bases were 13 and 25. And now that we've substituted in, all we need to do is use our order of operations. So actually 1/2 times 8, we could go ahead and do that, that's okay, is 4. 13 plus 25 would be 38. And 4 times 38 is 152. And our units were all in meters, looking at area, so our label should be square meters. And once again, the steps for our order of operations were to simplify the expressions inside grouping symbols such as parentheses, brackets, braces, and fraction bars. Evaluate all powers. Do all multiplications and or divisions in order from left to right. Do all additions and or subtractions in order from left to right.